Hey everyone, it's Kevin here, and today I'm going to be going over how to make a multiplayer tic-tac-toe game on top of UrTurn. Um, Before we get started, I'm going to show you guys what we're actually going to be building. So I'm going to go over here and click and play the final version. We're going to create a private room, and we should have the URL copied. I'm going to switch over to a separate window under a different account. Let me split like so. Nice. So here we can simulate basically two players. This is all happening over the internet. Um, if I make a move here, it shows up for this other player's view. If I try and make a move again, we'll see that it's not our turn, and we can just keep going, and it'll show that we actually won or lost depending on which view that is. Nice. The nice thing about this is that what you'll have noticed is that whenever I actually clicked create private room, all of this right here is taken care of you. So the act of clicking play where there's matchmaking and then creating a private room and sharing with others, you don't actually have to write code for that. UrTurn has already written code for it for you. Nice. So let's just get straight into it. So I'm going to open up my terminal here. So let's go ahead and run the command. Okay. Here it's going to prompt you for which tutorial that you're doing. The only tutorial right now is tic-tac-toe. So let's go for it. Once you hit enter, it'll start downloading the tutorial and installing any dependencies. Okay, cool. So it finished installing and it set up the template game that we're going to use. So we're just going to go ahead and do that. We're going to cd into first game. And we're actually going to open up an editor here, and you can use whatever editor that you want. I'm going to be using VS Code because it's a simpler experience. Let's go ahead and actually run the game in its current state by running npm run dev. Should load up this console. So this console here shows you the current game state, which right now, don't worry about all of these fields just yet. Just know that the console tells you basically what is the current state of this instance of a game, which is a room. Over here, we can try and add players. So I'm going to add one player. What you'll notice is that it'll display this error. So the front end is provided for you. You can make modifications to it, but for the purposes of this tutorial, we're just going to implement the back end and show how easy it is to actually implement tic-tac-toe and make it multiplayer. So here, it shows this error. That's fine. Don't worry about it just yet. If I click on any of the squares, nothing happens. And also, if I add another player, I can keep adding players, which doesn't make sense because tic-tac-toe is only between two players. Yeah, don't worry about this functionality not being implemented just yet. We're actually going to implement it. So to get started, let's actually go through the file and folder structure. Here, these are the two files that we're going to be modifying, the main and the util.js. These JavaScript files hold what's called the room functions. And room functions are, they look like this. So you'll export these room functions. They're going to be onRoomStart, onPlayerJoin, onPlayerMove, and onPlayerQuit. These functions are very important because what they do is that they take in the current state of the room and they return the result or the ideal desired state that you want to be. And this is really nice because basically you can implement essentially any logic on these separate events. So whenever a player joins, you can do whatever you want to this JSON object and specify, which pieces the player has or whose turn it is, etc. let's get started and get straight into actually implementing the very first function that gets called, which is onRoomStart. So we're going to go up here and find the function onRoomStart, and we have a couple of to-do statements that we should fill out. Note that this state is being returned here in this return JSON object. This basically signifies to the UrTurn framework that we want to modify the state. This state object here, we can put whatever we want. So we can put, like, I don't know, field1, hello, or we can even add nested fields, nested, and then, A5. Anything that's JSON serializable can go in this state object, and we get to control whatever it goes in this. This is really nice because it allows you to customize whatever game logic you have, and anything that UrTurn doesn't understand should just go in here. And this state will get persisted, and it will be passed across all the other functions. Cool. So let's start setting fields in it. So we want to say that the status is in-game. Sorry, not in-game. It's pre-game. It hasn't started yet because there are no players. We also want to say we want to initialize a couple of key values that are going to be used throughout the game. So we want to create an empty board. We're going to initialize it to a 3x3 board with all null values. So we're going to copy this. We're going to paste it down here, right? And we also want to keep track of which player's move it is. So we're going to do this by using a move index, and we're just going to set this to 0. So the first player to move is just going to be the first player in the players list, and we'll discuss that a little bit later, but for now let's just set it to 0. We want to set the player ID to player mark, which is a map. We have no players here, so we're going to make it an empty object, but the structure of this is going to look something like this, where it's going to be a player ID, and it's going to equal to something like mark x, which is an enum that is provided in the util.js. Yeah, nice. Okay, so the next thing we want to initialize is we want to set winner to null because there's no winner yet. It's still in pregame. And we're going to save this, which you'll notice that after we saved, it shows trigger hot reload on due to change. And this is really nice because underneath the hood, the UrTurn runner is basically hot reloading anytime you make modifications to your room functions, and it'll automatically load it up in the browser. Cool. So back to the console, we'll notice that we've actually populated this state object here with all of the initial values that we want. So status pregame, all the values in border null. Nice. It's also important that when we add players, this functionality still doesn't work. So we see that when we add a player, UrTurn actually adds a player here for us because this is managed by the UrTurn framework, but we don't actually set the player ID to player mark or anything here, or even start the game when we add 2 players. Nice. So we're going to go ahead and actually implement that. Okay, let's get rid of this to-do statement. Over here, this is the next function that we want to actually implement, and it's called onPlayerJoin. Yeah. So here, a couple things. What you'll notice is that there's some logic that's provided for you. This player's object is basically provided by UrTurn in the room state. So room state is every room has a room state, and this room state gets modified and changed with all the room state results that you return. For example, here, like we talked about earlier in onRoomStart, you have this state object. This state object is nested in room state, and you can modify and play with it however you want. Okay, cool. So we're going to go ahead and we're going to start implementing some of the logic. onPlayerJoin, whenever we have 2 players, we want to let the framework know, and we want to also track in our room that, hey, we're ready to actually start the game, and we should set the player ID to player mark to whichever marks each player gets. And we also want to set the status to in-game, right? So we're going to go ahead and do that. We're going to do state dot status is equal to status dot in-game. Nice. And then we're also going to do state dot player ID to player mark. And honestly, we're just going to make this simple. We are going to set the first player equal to mark X. In the future, we can randomize this, but for now, we're just going to keep it easy and manageable. And we're going to set it to O here, like so. Nice. So second player will be O, first player will be X. We then also want to return this, just so UrTurn knows that we're modifying the state object. So we return the modified state. We also want to tell the framework that, hey, now that we have two players, we don't actually want any new players to be added to the room. So we want to set joinable, which is a special metadata field, and we're going to set it to false. What this does underneath the hood is it basically means that anytime a player clicks play and joins the matchmaking queue, UrTurn will guarantee that whenever joinable is false, we will never call onPlayerJoin with another player. And this is guaranteed via transactions. So keep that in mind. onPlayerJoin will never get called if joinable is set to false, and you can be guaranteed that. Okay, cool. So we're going to save this, and it'll hot reload the runner. We can go back in the runner. We're going to start adding players and making sure that it does what we expect. So we're going to add a player here and go back here. And what we'll notice is that the players, yes, we do have another player. Nothing happened, but that's what we expected because we didn't want to make any changes when only a single player joined. When a second player joins, we're going to take a look here, and we're actually going to see that the player ID to player mark gets populated as we expected. We also see that the status is in-game and that joinable is now set to false. Cool. If we try and add another player, what you'll notice is that you'll get an error that we cannot add another player because the joinable metadata field is set to false, and that is exactly what we expected. Something that you'll notice here is that if let's just say one of the players quits the room. If user 1, we can force them to quit like so. You'll notice that UrTurn removes them from the players list, but we don't actually do anything with that information. We would actually want to set the game to end and default the winner to the other player that's left. So let's go ahead and implement that logic. Okay. So we're going to scroll down. We're going to go to onPlayerQuit here. And let's think about how we want to implement this function. So we have this piece of logic provided for us by default, which is this was created in the tutorial whenever we initialized it. State.status is equal to status endgame. The reason why we want to set this to endgame is because anytime a player quits, we automatically just want to assume that the game is over, and we want to display in the UI that the game is over, right? So we just say state.status is equal to status endgame. Now, there's two separate cases that we want to handle. We want to handle if there's only one player remaining, or let's just say a player joined for the first time and they're the only player in the TicTacToe board and they want to leave immediately, right, before another player joins. That's what this second case handles. So let's go ahead and implement both of these cases. So we're going to start with one player remaining. This is a little easier. We want to default the winner to be the only player left. So we're going to do that by doing array destructuring with the players list, and the last player here is going to be the winner. Yeah, okay, cool. So we want to modify the state.winner to be winner. right? And we want to go ahead and return state here. And we also want to return that the finished is actually true. So this is another special metadata variable, similar to joinable. It's just a Boolean value, and it tells the UrTurn framework to do special things based off of this. When finished is set to true, you are guaranteed that none of these remaining functions will ever be called because the room is finished. So we won't actually allow any more room functions to be handled when finished is set to true. Similarly, also finished setting to true allows the UrTurn framework to index this room state properly and display it to players so that they can view any finished room that they recently played. So we're going to get rid of this. Nice. And we're also going to want to implement the second part, but before we do, let's make sure that we have this case handled. So we're going to add 2 players, and we're going to force user 1 to leave. And what we would expect is that winner is set to user 0, and it is. So when we forced it to leave, user 0 is set here. Very nice. And also status is endgame, and finish is true. Okay, cool. Let's go back here. And let's actually handle whenever a player leaves and there actually is no winner. So we're not actually going to modify the winner of state because we don't have to. There is no winner. We just want to set it to true, and that's it. We can also set joinable to false, but this doesn't matter because basically this room will be when it's finished, it's implied that joinable is going to be false. So we don't actually have to set this. I can just remove that. And let's go back here. So we're going to run through that case. We're going to add a player, and we're going to immediately force the player to quit. And what you'll notice is that finished is going to be set to true, and the status will be an endgame, which is exactly what we expect. Nice. So we implemented 3 out of the 4 functions already. Now we actually want to implement the core logic of TicTacToe, which is all going to go under the onPlayerMove, which onPlayerMove is basically what do we do whenever a player makes a move. And you might be wondering, what actually is a move? A move can be any JSON object that you specify on the front end. So if we actually go into the front end here and we inspect some of the React.js files, you don't actually need to understand React for now, just follow along. What you'll see here is that I'm importing this client from the UrTurn client, and down here where I call client.makeMove, what you'll notice is that it's setting up this onClick handler that whenever I click one of the squares on the TicTacToe board, it's going to attempt to make a move with X and Y, X being the row number and Y being the column number. So keep that in mind that this move can be any JSON object. So even though we're making it X and Y for TicTacToe, it doesn't have to be that case for any other game. Nice. So let's go back here. And yeah, so now that you understand what the move object it looks like and how onPlayerMove is called, it's called by the client.makeMove, we can actually go ahead and implement the logic to handle this. So we want to start off here by doing some basic validations. Keep in mind that onPlayerMove may be called at any point whenever there is a player in the room, right? So in the case where there's only a single player in the TicTacToe board, that player may actually fire the onPlayerMove event. It does not matter if the status is in game, right? So we want to actually implement validation logic that makes sure that the game is in progress. So let's do that right now. And let's do a simple if state.status is equal to, actually not equal to status.inGame. Okay, And then if that's the case, if it's not in game, then we want to immediately throw an error with a useful message. And this error will get propagated to your game front end. So let's just say that game is not in progress. You cannot make a move. We're going to save this. We're going to go back here and we're going to try this. So we're going to add a player. And we're going to click some of the squares, and what you'll notice is that the error message shows up in the top right corner. Cool. Before it did not. So let's go back and let's implement more validation, and let's finish that up before we check again. So we're going to do, what if a player makes a move and it's not their turn? Well, that's exactly why we kept track of this player move index. We want to make sure that the current player trying to make a move it's their turn. So we're going to do players, and we're going to use the player move index to get the what should be the player's turn. We're going to get their ID, and we're going to see if it's strictly equal, if it's not equal to the current player's ID that's trying to make a move. And if it's not equal, then we should throw a new error and say, hey, it's not your turn. We're going to save this, and we're going to try this out. So we're going to add 2 players this time. Now that we have 2 players, it's saying here that we should wait for user 0 to make their turn, because currently we're user 1. But I'm going to try and make a turn anyways, and it's going to show the error, hey, it's not your turn. Cool. That's what we expect. So let's go back here and let's implement the last validation logic that we need to do. Is we need to make sure that when a player moves, they don't actually mark the board where there's already a mark. So the way we check that is we just see if state.board, and then we're going to actually use the move indexes X and Y, and we're going to see if that exists. So hey, does this not equal to null? If it isn't null, then that means that they're actually trying to make a move where there's already a mark. So we want to throw an error, throw new error. Hello, someone already moved here. Okay, we're going to save. And we're going to go back here and we're going to add 2 players. But the thing is that we've actually already done some client-side logic where when a player tries to make a move, we actually haven't implemented the make move yet. Okay, so we'll check this after. Let's go ahead, now that we finished the validation logic, we want to actually implement actually making the move with the player. So over here, we want to set board X, Y. We want to set state.board X, Y, and we want to set that equal to the player's mark. But we conveniently have this player ID to player mark that we set up previously. We're just going to say player.id is equal. Oh, sorry. Yeah. So we're just going to set it equal to their mark. Cool. If we save and we go back here, we try and add 2 players, and I make a move as user 0, it'll actually show the mark and it'll propagate it to user 1's view, right? So if I split screen this and I show you move, hey, it's not your turn. Oh, interesting. What you'll notice is that although we propagate, one, it doesn't check if the game is won, but also it doesn't flip the turn of the player. So let's fix that. We're actually going to set the player move to the next player. So that is, we can do that by doing player move index is equal to player move index plus 1, right? Okay. The problem with this is that it'll just keep incrementing past the player list. So we actually want to do a remainder function that makes the remainder, that loops it back to 0 to 1. So what this looks like is if player move index is equal to 1, let's just say, and we add 1 to it, it'll be 2, and then 2 mod 2 is just going to go back to 0. So player move index will just loop back all the way back to 0. Okay. Let's save this and let's go back here. Let's add a player. Let's add our second player. Let's split screen it again. And we can see here it's your turn, make a move. So we made a move and then it flips. Very nice. So we can actually set up different moves. Now what you'll notice is that, yeah, again, we still haven't implemented what to do when a player wins. Or whether or not it's a tie. So we need to fix that logic. But before we do that, we want to actually confirm here that a player cannot make a move where there's already a move. The thing is that our front end is smart. It doesn't actually allow you to click and fire an event. So we're going to modify the front end to actually do that and make this simple. So rather than setting disabled here, we're going to delete this so it doesn't actually disable the button. We're going to go back. Now what you'll notice is that the front end is hot reloaded. So we don't actually need to replay everything. We can just use the new front end, and when we click a button here, it says, hello, someone has already moved here. Very nice. So our validation works. So I'm going to undo that. Now we're going to actually implement what to do when the board is finished. Okay, so this is the core tic-tac-toe logic. We need to first implement this evaluate board function before we can do any of this. So in this evaluate board, you'll find this under your util.js file. And there are several cases that we have to go through. We, one, need to check if there's a tie. We have to check if there's a winner along the rows, columns, diagonals. And by default, we should just return that, hey, this is not finished because there was no winner and it's not a tie. So let's first do the default. Let's return finished is false. Okay. Cool. And then over here, we're going to actually, this is, we need to check for a tie after we check for a win. The reason being is that one of the moves may have caused the board to win, it would be incorrect to assume that it's a tie if the board was filled up. So let's first write out the code for whether or not it's a tie because it's simpler. We're going to say const is tie is going to equal. We're going to use this board argument. Also keep in mind that this is the return value that we want to provide. So keep that in mind as you're implementing the evaluate board. So we're going to do board. We're going to do every, right? And then we're going to do line. So we want to basically make sure that every value in board satisfies this predicate function. Okay, that's what the .every function does, and you can read the doc string later on your own time, but it should be pretty straightforward. So now each element in board is really just another list, which is going to be each row. So we're going to do row here, and we want to do the same thing. We want to do row.every, and we want to check if every value, so mark, is not null. If every value is not null, then what that means is that this board is completely filled up and it should be considered a tie, right? So we're going to take this and we're going to say, if is tie. We want to short circuit and return that finished is actually true. And we actually want to return that the tie is actually true as well. Okay, cool. So we're going to save this and we're going to test it out and to see if it's actually a tie. But we can't do that yet because we haven't implemented modifying the actual state based off of the result from evaluate board. So we're going to go ahead and do that really quick. If result.finished, remember we return finished is true in the case of a tie. we want to set the state.status to status.endgame, right? We also want to make sure that the winner is set properly, but if it's a tie, we don't actually have to do anything, so let's not do anything right now. We can return state here. We can also tell UrTurn that the room is finished, so we're going to say finished, set to true. Similarly, like how we did in onPlayerQuit, we want to tell UrTurn that the game is actually over. Cool. Because we haven't implemented a winner yet, this is just for a tie. Let's test it out and actually make sure it works. So we're going to go back to here. We're going to add our 2 players, split screen it again. We're going to make a move. And just fill up all the board. It doesn't matter if it assumes that this is a tie. We just want to make sure that when the board is filled, it marks as a tie, and it does. And we can take a look at the state, and it says that the status is endgame and finish is true, and winner is still null, which is exactly what we expect. Nice. So let's actually implement the winner logic here. Okay, if we go back to util, we need to now implement the bulk of the TicTacToe logic. We need to check the rows, we have to check the columns, and we have to check the diagonals. We also need to make sure that while we're checking these lines, we want to make sure that the mark is not null, that it's actually an X or an O. And using the X or O mark, we have to determine which player actually won. So I know that's a mouthful, but we can simply start and just go for it, and let's do rows. So we're going to do let I is equal to 0. We know that there's always going to be 3 rows, and we want to increment it by 1 each time. Nice. So here we're going to check the rows. Okay. So we want to index our board and get the first mark for row number 1. So we're iterating through all the rows. So we're going to do const mark is equal to, we're going to say that the first value is board I and 0. Okay. Nice. Cool. So this allows us to basically see if the value is null or not. And that's going to be important whenever we're checking the win condition. We also want to see is const is same. We want to see if the entire row is the same. So we're going to do board I is 1 is equal to mark, and board I 2 is equal to mark. So the thing is if they're both strong equals to the mark, then we know that the entire row is the same. So we can do something like this. So if mark not equal to null and is same, then we want to return that, hey, the finished is actually true, and we want to return the winner. But here's the thing. We actually don't know who the winner is, even though we know the mark. So what we can do here is we can just figure out who the winner is. We have this player ID to player mark, and we want to find which player has the same mark. So we can do const, something like const winner is equal to players.find, and then we're going to take the current player, so just do player, map it to player.id is equal or sorry, player ID to player mark, indexed by the player ID is equal to the mark, and this is guaranteed to find a player with that satisfies this. So we're going to return this, and we're going to say like so. Nice. So this should return a winner if the rows is set to true. I don't know what's going on. Why is this expression expected? How did I mess up here? If I do this, does that work? Okay, no. I think it's just VS Code. Yeah, it's just VS Code being laggy. Okay, let's make sure that a winner is chosen whenever we have a player win on a row, not a column. So let's go ahead and just start making moves, make moves, make moves. And okay, it says it's a tie. That's interesting. Why does it say it's a tie? Oh, that's right, because we still haven't implemented what to do when there is a winner given the evaluate board result. So let's go ahead and do that. We can just do something like this. If result.winner not equal to null, we can just set the state.winner equal to result.winner. Cool. So let's give it a shot again. Let's add a player. Let's add another player. Let's make moves, make moves. Let's check the rows. Okay, cool. So it does actually work, and it says that we won. Nice. Okay, so now we have to do the rest for the columns and diagonals, and I recommend pausing here and just going ahead and trying to implement this on your own. Let's go ahead and do this. We're going to copy this over, and rather than checking rows, we're going to check columns. And the columns is going to be this flipped. So we can just take this, flip that, and save. Let's make sure that the columns work. Let's add player. Let's add another player. Split screen it again. We're going to do this, and nice, columns work. Cool. Okay, now we have to do the tricky one, which is diagonals. And for diagonals, we're just going to hard code it. We're just going to say const is same diag1. So the first diagonal is just going to be, it's going to look something like this. Equal to, and equal to this, and equal to this. Okay. We're going to use strict equals. Like so. Okay. Now we want to make sure that we get the actual values correct here. I just realized we don't need this third equals. So we want to do starting top left down to top bottom right. So that's going to just be 0, 0, 1, 1. And then 1, 1 is equal to 2, 2. So to help visualize what that diagonal actually is, we can go back here in the main initial. It would look something like this. So this is the diagonal that we're checking, right? And the diagonal that we want to check next is going to be the opposite, which is just going to have some of the values rotated. But first, let's do if is same diag1, right? And board 0, 0 is not equal to null. We want to make sure that the mark is not equal to null. We're going to do the same exact thing. We are going to return the winner here because it's assumed that it's a winner. And mark here, we're going to just use 0, 0 here. Okay. We're going to do the same thing for the second diagonal and just flip the values here. So this should be a 2 instead. 1, 1 should stay the same. And here we should be 0. Okay, very nice. And honestly, we can just use board 1, 1. The diagonals are going to have the same mark because they both go through 1, 1. So we can just reuse the same mark value and go here. Do this. Yes. Yes. And here. And then same diag should be same diag 2. Okay. Very nice. Very nice. Let's save that. And let's go ahead and make sure that things work. So add player. Cool. And we're going to check the diagonals. Nice. So the diagonals work. And you can check the second diagonal, but I don't think we need to. Cool. So we implemented TicTacToe, all the basic logic for all the room functions. Um, just to quickly recap, we implemented onRoomStart to provide the initial board game state. Then we needed to handle what to do and how to modify state when a player joins. Um, we also needed to handle the win conditions, which is onPlayerMove, in all the various edge cases. We had to check the rows, columns, and diagonals. Also keep in mind that onPlayerMove takes any move JSON object that gets propagated from the front end, and we saw that in the React file here. And we also needed to handle edge cases when a player quits a room with onPlayerQuit. And that is whenever there are two players and one of the players leaves, we want to default the winner to one of the players. So we implemented all of that logic, which is awesome. But you're probably wondering, hey, like, this is running locally on localhost 3101, and I can't actually play this game with a friend. Well, I'm here to show you how to actually do that, and we can actually do this very easily with UrTurn. The nice thing about this is that all you had to do was implement these 4 functions, and for free, you basically get all the room logic that schedules and scales these functions, as well as matchmakes players to join the same room and private rooms. So let's go ahead and do that. To do this, we're going to need to follow the instructions on deploying your game. Now, to deploy your game, you have to make a GitHub repo. So we're going to go into GitHub. We're going to create a new repository here. And we're just going to call this my first UrTurn game. And the description will be, this is fun. We're going to make this public. And yeah, that's it. So let's create a repository. Okay, cool. So we need to actually initialize our repository now. And we can do so by following the instructions provided by GitHub already. So we want to follow the instructions for create a new repository in the command line using all of this. Okay, so we're going to go back into our repo here, and we're going to initialize the Git repository. So we can do that by running git init. And then we can also run git add. So we're going to want to add all the files that we created earlier. So I'm going to run git add hyphen capitalize A. And then we're going to commit everything. Just call this first commit. Then we want to set our branch. We're going to name our branch main. It's important that you name your branch main so that the GitHub Actions will pick it up. And we'll talk about that in a second. So set our branch to main, and we want to add, we're going to copy the link that was provided in the instructions on GitHub. We're going to paste it. What this does is it adds the actual repo origin to your local Git. Now we're going to push it. So what this does here, git push -u origin main, is we're actually going to send all of our repository files to GitHub so that it can be tracked on the website. Yeah, so we're going to go back to the website and we're going to refresh. And nice. So we see all of our files here. And then the GitHub Actions should start running. And we can view the details of it here. Okay, so the publish just finished. We can see that it ran everything, and it stitched together the front end and the back end files into an artifact, and it pushed to this separate branch called publish. So if we go back to our code and we check the new branches, we can see that there's now a publish branch. What we want to do is we want to actually look at this latest commit. So it was committed a minute ago, and we're going to use this commit value whenever we create the game. So let's go back to UrTurn. Let's go to the create console. and let's create a game. So we're going to name this, I don't know, my first game. You can name it whatever you want. And we want to copy the GitHub URL, which is going to be this right here. We're going to copy that GitHub URL. We're going to paste it here. And we want to get that commit SHA. Now, this commit's very important because it tells UrTurn which code to actually run for your game. And it allows you to update your code whenever you want to run a different version of code. So we're going to copy this, and then we're going to go here. We're going to say, hello world, TicTacToe, play my awesome game. Friend. Okay. And we're going to create it. Nice. And it should immediately load up here. And we can actually, let's take it for a test run. So let's create a private room. And it loads in the game. Let's actually open this up in a separate tab, which we can do here, like we did originally. And what you'll notice is that the game actually works. And let's try and make a move when we're not allowed to make a move. And hey, it shows the same error message that we had originally. And yeah, pretty nice. So there you have it. Let's go back here. Some also nice things that you can do is that you can edit simply by just going here if you want to update the commit. And if you want to see what version of your game is deployed, just go click this link and it'll link you directly to GitHub, and it'll show you the artifacts. So if you need to debug, it can show you exactly what's going on. Cool. Nice. So that took like maybe a few minutes, and you were already able to get your game up and running and playable by anyone. And it should show up on the front page. Nice. We have some good tester games here. If we refresh here, it'll show up right here under my first game. If you enjoyed this video, please give it a thumbs up and leave a comment. And feel free to join our Discord where we discuss and do feature releases. We also do a lot of fun events. For example, we're hosting a game jam in a week or so on the 26th to the 27th. So I highly recommend checking it out. There are prizes. And honestly, the games are pretty simple. So you might have a good chance of winning because I think we only have like maybe 4 or 5 people. Cool. Thanks for watching, everyone, and I hope to see you guys in the next video.